start recording, but we will start the talk only in 2 minutes.
Excellent.
So now we're recording any informal conversation. So Mikhail, can you start by telling us how is life in Vietnam? Can you expecting visitor for postdoc or just a sabbatical? Sounds like a fun place. Is it a fun place?
It's a very fun place. I mean, if you're considering doing a sabbatical, I'm very happy to host you here. For postdocs, I don't have funding right now, so that might be a bit tricky. But I think we'll be hiring some more research-focused faculty in the next year or so you can keep an eye out.
Hi, Derek. So what was your motivation to move to Vietnam? It's very unique.
I think the main motivation is because it's a very ambitious university project. So
I see.
probably never heard about this university. It has been founded 5 years ago with the goal of becoming a top international university. So that's a very ambitious goal.
Sounds like a very good motivation. So we will start in.
To see you. And I just want to say I'm on vacation in Greece, but so I will close my video, but I will be with you.
I can add.
Okay, we are in vacation, but everybody's in vacation, but you see that we have nice attendance. You are pretty famous to make people to join from their vacation.
Happy to hear.
Just a minute. Okay, I think we can. I think we can start. Let's see. And I'm the host today, and it's an honor for us to invite to welcome Mikhail Spector. Mikhail just finished his PhD 5 or 6 years ago and was already in 3 universities. I think he was in Pompeu Fabra, and then in Warwick, and now he moved to Vietnam, which I found it creative, but it's turned out to be his career path. He's a creative person. We invited him because we recently read papers that I really like by Mikhail Spector and Derek Wolf, who's here too. And I asked him to, and I think this is an important paper, and I want to hear more about it, and I want everybody to know. And Mikhail is also, although he's very young, there's already two of his papers that I remember the results, which is not easy for me. So I noticed his early results on the reverse compromise effect, and definitely the results of this last paper, I think, is something that I will remember, that everybody looked at the sampling paradigm, and he and Derek and Mikhail looked at it again and found something that an important thing that everybody missed. So go ahead, Mikhail.
Thank you, Ido, for the nice introduction, and thank you also for inviting me to present this project here. This paper is called Predecisional Information Search Adaptively Reduces 3 Types of Uncertainty, and what's quite a long title. I hope we have some very important takeaway messages that I hope to share with you today. So as every JDM talk begins, we make so many different decisions in our everyday lives. For example, whether to take medicine against a headache, what kind of stocks to invest in, or other decisions such as whether and whom to marry. Now, the slightly different twist to this talk today is that I will be talking about information search. So all these kinds of decisions that we make in everyday life, they have an information search process that precedes the decision making itself, right? So every choice that we make has to be based on some information after all. And so in many situations, the information search is costly, right? So for example, if you're going to a new restaurant, then you have to forego the opportunity to eat at your favorite place, and you can only come there the next day or for the next meal. And this exploration-exploitation dilemma has gathered quite a lot of attention and led to a lot of research. So you might be quite familiar with this type of literature. However, in this project, we're not looking at costly information search, but we're looking at non-costly information search. So for example, when you're thinking about whether to marry or not, instead of going through several marriages to identify whether this is something for you or not, you can think about couples in your social circle and think about whether they are happy or not after marrying, and base your decision on this sampled information. And these kinds of information search processes are quite common in the 21st century. So we have a lot of modern information technology to make these kind of information search, to make this information search possible. So for example, we probably all use all various customer experience sites where we gather ratings for all kinds of products. You can do this for financial services, or you can even do like simulations for diseases. I think we all remember COVID times when we could simulate our risk of getting exposed and getting COVID, right? So the fundamental question that we ask ourselves in this project is, how do people do this, right? So how do people search for information before making a choice? So the dominant idea in the literature is that information search follows some form of cost-benefit analysis. So when we're looking for information, we have some expected gain of obtaining more information, but we have also a cost of acquiring said information. And past literature has reported several findings that support this kind of cost-benefit analysis, and in that people adapt their search behavior based on the costs and the benefits of information search. So for example, if the value of information increases, for example, by increasing the stakes of a decision, people search for longer. If there's more uncertainty, then people also search for longer. On the other hand, if the costs of information search increases because maybe somebody else will make a decision first, then people search for less. However, there's only very few insights into the mechanisms that underlie free information search, right? So what drives free information search? Let's first look at the expected gains, right? So we're talking about the cost-benefit kind of framework. So what does the literature tell us about the expected gains? So the dominant approach is that the benefit of search is uncertainty reduction. So by engaging in information search, we reduce uncertainty about the available choice option. Now, if we look a little bit deeper in the existing literature, then we find that most often uncertainty is defined as an estimation error within a specific statistical model. So people are expected to have a statistical model in mind, and when they engage in uncertainty reduction, they reduce the uncertainty within the statistical model. Now, this view of uncertainty is quite narrow and not very general. So for example, Martin Spekenbrink has published a very nice paper a few years ago that has a very nuanced view on uncertainty and that distinguishes between different kinds of uncertainty. So for example, there are other higher order uncertainties that are relevant for decision making. For example, people might have uncertainty about how the structure of the environment looks like, right? So basically, what can they possibly expect from the environment? And this environmental knowledge is quite essential to be able to reduce estimation uncertainty or to reduce estimation of decision relevant criteria. So on the other hand, it's also important to consider because there might be different kinds of search strategies necessary to reduce different kinds of uncertainties. For example, if you just want to reduce estimation uncertainty, then sampling from the option with the highest estimation uncertainty will generally reduce the uncertainty, the estimation uncertainty. However, if you engage in this information search strategy, you might not necessarily reduce structural uncertainty at the same time. Then, to make things even more complicated, there might be yet other kinds of uncertainty that are not only estimation or structural uncertainty, or people might even engage in information search processes that are not uncertainty driven at all. For example, if you're familiar with instance-based learning, here the model assumes that people engage in information search based on value and not based on uncertainty. Now, let us turn to the cost side of things, right? So what does the literature tell us about the cost side of information search? And in terms of cost, basically the question that we ask ourselves is how and when do people decide to terminate information search, right? So when do they decide to stop looking for additional information? There are a few examples in the literature that provide us with some approach to termination of information search. For example, there are a few evidence accumulation models where information search follows a classical diffusion model kind of approach, and as soon as there's enough evidence in favor of one option, people terminate information search. There are other models that propose that information search is based on surprise or volatility. So as soon as people think there's nothing more, there's no more surprises to be seen, they terminate information search. If we go beyond the classical kind of information search literature and look, for example, in animal foraging literature, then we find that there's also non-uncertainty based termination strategies. For example, many animals engage in what we call a fixed sampling rule, where they just decide in advance how many patches they want to forage in, and then they terminate their foraging process as soon as they have sampled these patches. On the other hand, also humans might engage in, for example, optional stopping. So we might wait until we observe a certain pattern or observe a certain outcome and then terminate information search. So all of these kinds of costs come together, and then beyond this, there might also be a type of uncertainty which we call computational uncertainty. So maybe people engage in information search or they engage in some of these strategies to simplify the computational processes. For example, by engaging in or by deciding in advance how many pieces of information to sample, let's say 10 pieces of information, and then stopping after 10 pieces of information, it's very easy to compute an average. And finally, it might also be possible that people engage in a sequence of different strategies depending on the situation that they are located in. So really in the literature, there's a lot of uncertainty about how people engage in information search. So how do we approach this problem? So in this project, what we do is we want to identify the drivers of non-consequential information search by analyzing over 1 million information search decisions made by over 2,500 individuals. To do so, we rely on the sampling paradigm. I would assume that most of the audience here is quite familiar with the sampling paradigm, but I will briefly repeat the core features of the sampling paradigm anyway. So people start out by observing usually 2 unlabeled boxes, and then they are free to sample as much information in any order as they want from each of these boxes until they feel confident that they have obtained enough information. So here in this case, for example, the person decided to first sample from the left box, then from the right box, then from the left box again, then from the right box again. And then this person decided to terminate information search and make a single consequential choice by getting a new outcome that they have not yet observed. And the main benefit of this kind of paradigm is that information search and choices are very cleanly separated. So whereas most people who investigated the sampling paradigm have focused on the choices that people make, we focus on the information search process that precedes the choices. So the way we do this is that we rely on a formal measurement framework that allows us to quantify and specify different information search behaviors. And then we use this computational framework to address two fundamental questions of information search, which might not be very surprising given the introduction, right? So the first one is, how do people decide where to look for information, right? So how do they allocate samples during information search? And the second question is, how do people decide to terminate information search and make a consequential decision? So these are the two questions that we hope to answer in our project. I will first give you a brief overview of the database that we used to run this project. So this is just to give you a brief overview of what kinds of decisions our analyses are based on. So we used Dirk's meta-analysis in Psychological Bulletin from 2018 as the database, which included 28 papers that form 80 datasets in total, and the entire dataset includes roughly 4,500 individuals who make roughly 45,000 decisions. And in all these decisions, people choose between two lotteries using the sampling paradigm. Now, we reduced this data set by only including autonomous sampling paradigms where people are really free to choose how much and from which option to sample, and only those decisions from which people sampled at least once from each option. And after these exclusions, we end up with roughly 2,500 individuals from 55 data sets or 23 papers. They make about 40,000 decisions and about 1 million samples. A majority of the decisions are between two lotteries that contain only gains or zero outcomes. About 30% of the lotteries contain only losses or zero outcomes, and about 13% of the decisions involve mixed lotteries. A majority of the database includes risky versus risky options, where both options have at least two unique outcomes. About a quarter of the problems involve risky versus safe decisions, where one option has at least two unique outcomes and the other option has only one unique outcome. And 1% includes safe versus safe decisions. If I remember correctly, that's basically Ido's, one of Ido's papers where there was safe versus safe decision. Just to give you a general idea of the choice and sampling behavior. So people choose the option with the highest expected value in about 59% of the cases. If we look only at the observed outcomes, then people choose the option with the higher observed mean in 74% of the cases. People tend to avoid risky options, so they choose the less risky option in about 57% of the cases. They draw about 26 samples on average, and this ranges from 2 to 750 samples. And they switch, the switching rates are quite variable. So on average, they switch once every 3 or so sampling decisions, but this is very variable. Okay, so let me now introduce our measurement framework. So what we do is we use a measurement framework that relies on a Bayesian observer. So the idea is that people have prior beliefs about the properties of the outcome distributions that underlie the choice options, and then they update these beliefs with incoming information. Right? So a standard Bayesian model with priors, with observations that then form posteriors. And so we focus, within this framework, we focus on three main drivers of information search. So the first main driver of information search is the one that is predominant in the literature, which is the estimation-driven search. So people obtain information with the goal of reducing estimation uncertainty. We introduce a new driver of information search, which we call discovery-driven search. And here, the main motivation that drives information search is discovering yet to be seen unique outcomes. So people expect that maybe they haven't seen everything there is to see, and they specifically target the options that might have these outcomes. And as the third information search strategy, we have value-driven search, where people sample from the option from which they they expect the higher expected value. So this is the intuition or the general measurement framework. I will not go into the equations unless there's interest and I have time at the end. But I want to give you a little bit of an intuition about how this works, right? So the Bayesian observer, which represents people in the studies, the goal is to identify the option with a higher expected value, right? So there's two options, and what the Bayesian observer learns is the value of the outcome distribution. So we are assuming, as an auxiliary assumption, that the outcomes from all options come from a univariate normal distribution with an unknown mean and unknown variance. So this is a crucial assumption to really simplify the measurement framework. But at the same time, this is also an assumption that we find psychologically and statistically quite plausible. Psychologically, because there's been a lot of research that finds that people have a very strong Gaussian bias in their perception of distributions. On the other hand, with enough samples, due to the central limit theorem, things become kind of Gaussian anyhow. So we find this auxiliary assumption quite plausible. And then using these two assumptions, we follow a model developed by Andrew Gellman and colleagues, where which is basically about normally distributed data with a conjugate prior. Prior, in fact, is a very core feature of our modeling framework, because priors encode prior information, right? So what we do is we try to model the experience that people make throughout the experiment as closely as we possibly can, right? So what we do is basically we first start out with an informed prior that uses some external information. For example, the expected duration of the experiment, or the bonus that participants were promised for participation, to form an expectation of how good options will be in the experiment, right? So we use the distribution of expected values of all options that people will encounter in an experiment as an informed prior in our model. And this really reflects this scenario that participants have a vague idea of what they can expect in a study. Now, let me give you an example of how things look like, right? So I know it might be a little bit unintuitive to just think about like Bayesian observers and an updating process. So here's a specific example of how this process looks like. So in the beginning, people have some expectation about how good things will be. So in this case, they might be expecting that the average, that the expected value of the options will be 0.26, and that the standard deviation is about 2.8. Then they observe an outcome of 4 from option A. They update the expectation from option A. So in this case, now they would expect a value of 2.13. At the same time, the uncertainty has increased because the outcome of 4 is quite far away from what they have been expecting. So the uncertainty has increased. Then they observe an outcome of 0. They adjust the expectation down again. So now they might be expecting something like 1.42. The standard deviation has decreased because they have obtained much more information from the option than before they had any information. They might observe another outcome of 4. The expectations update accordingly. Then they might see another 4, update the expectation accordingly, and so on. And the same goes if they sample from option B, and for example, they see an outcome of 3, then they adjust the expectation, which affects both the reward expectation and the uncertainty surrounding this reward expectation. And as they obtain more information, this uncertainty reduces. Okay. I hope all of us have an intuition about how the measurement framework works in our study. So let us get to the first set of results.
Just clarification result. So
yes.
So by the way, my camera is broken, but you hear me, I assume. So,
yes,
but this example, you don't talk about the stopping rule. You just this example only describes the accumulation, your belief about the average, right?
Yes. So in this example, this is how the belief about the average reward develops as people obtain new information.
Okay. Okay.
It does not yet include an allocation rule, and it does not include a stopping rule either.
Okay. Okay. I just want to make sure I didn't miss anything. Okay.
Yeah. Okay, so we'll spend quite a bit of time with plots that fit into this illustration format. So I want to first introduce it a little bit in detail. So what we can see here is on the x-axis, we can see the relative sample within a sequence of samples that goes from 0 to 1. So basically, you can think about of this as 0. That's the very first sample that people draw in the information search sequence. And 1 is the very last sample that they have seen in the information search sequence. And everything in between is just a linear projection. So if people sample 5 times, then the first sample is 0, and the 5th sample is 1. If people sample 750 times, then the first sample is 0, and the 750th sample is 1. Right? So we just linearly compress the entire search sequence into the range of 0 to 1. On the y-axis, we can see how many, or the proportion of samples that is allocated in line with a specific search driver. So for example, the first search driver that you can see here is now value-driven search. And on the y-axis, you can see how many of the samples were allocated to the option that had a higher expected mean at the time of the sampling. That's how you can interpret the plot that you can see here, right? And what you can see here is basically that throughout the entire information search sequence, people do not tend to sample from the options with the higher expected means. Only towards the end, you can see a slight increase of sampling from the option with the higher expected mean, which is a pattern of results that we have known in the past. Dirk called it the Gaze cascade-like effect in his meta-analysis. So if we look at estimation-driven search, so with the goal of reducing estimation uncertainty, we find now that the signal is quite a bit strong. So throughout the entire sequence, people tend to sample from the option that has the higher estimation uncertainty, and this peaks somewhere around the midway point. Now, importantly, the new information search mechanism that we propose, which is discovery-driven search, is most consistent with information search decisions throughout the entire sequence. So for most of the time, what people are mostly engaging in is discovery-driven search, which means that they are looking for outcomes that they might have missed. So what does it mean, looking for outcomes that they might have missed? Here you can see a breakdown of the previous plot according to some epistemic states. So as I mentioned in the database overview before, we have different kinds of problems in the database. So we have some problems where people face two risky options, and we have some problems where people face one risky option and one safe option. So, and here you can see a breakdown according to three different epistemic states. So the first panel is about risky, safe problems. So where one option is risky, one option is safe, and where they have observed two outcomes from the risky option and one outcome from the safe option. In the middle panel, you can see risky versus risky decisions, where they have observed two unique outcomes from one risky option and one unique outcome from the other risky option. And then on the right-hand side, you can see risky versus risky decisions, where they have observed both outcomes from both options. So they have observed two unique outcomes from one option and two unique outcomes from the other option. Importantly, discovery-driven search is the same as estimation-driven search in the risky in panel C, where they have observed both outcomes from each risky option, and in panel A, where they have observed both outcomes from the risky option and the one outcome from the safe option. Why is this the case? Because there's nothing more to discover, right? They have seen all possible unique outcomes. However, if people have are missing a unique outcome, which is the case in panel B, where they have only observed one outcome from the risky option, you can see that people really try hard to find the missing outcome that they have not yet observed. Right? So here's really where the discovery-driven signal is the strongest. Now, this analysis extends beyond the simple two-outcome case. Here we have a situation where the risky options have exactly three distinct outcomes. And you can see that when people are missing one distinct outcome from one of the options, then they try really hard to find this missing outcome. And as soon as they have found this missing outcome, they just continue sampling in line with estimation, with reduction of estimation uncertainty. So you might think, how is it possible, right? So how can people know if they have observed two outcomes from one option and one outcome from the other option? How can they possibly know? So that's why we tested a couple of corollaries of this new strategy, right? So it's a new strategy. So we can derive predictions and look in the data if these predictions also occur in the data, right? And here the important part is really people need to know when they have something that they can discover and when there's nothing left to discover and they can stop engaging in discovery-driven search, right? And for this, people need to know how many outcomes can they expect from each of the options in the experiment. And we consider three possible mechanisms by which people can learn about what they can expect in the study. The first one is based on experimental instructions. Maybe they learn from the instructions how many outcomes they can expect in the study. The second mechanism is people might learn as they go from problem to problem how many outcomes they can expect. And finally, people might use the difficulty of the decision as an indicator of how of whether they might be missing something. And I will briefly present some analyses related to each of these mechanisms in the next couple of slides. So first, in terms of instructions, there was one study in our database, which was conducted by Glöckner and colleagues, and I believe Andy is also here in the audience, where they explicitly manipulated how, or they manipulated between groups if people received instructions about how many outcomes they can expect in the study. And so what we predicted for this subset in our database is that people will engage in more discovery-driven search if they are in the condition that knows how many outcomes they can expect, and also that this effect will be stronger at the beginning of study, because as the study progresses, people have gained their own experiences about what they can expect. And indeed, we can confirm these predictions. So if we just look at the first 3 problems that people encountered in this study, then there was a difference of 7 percentage points between the conditions in the extent to which people engaged in discovery-driven search. And if we look at all problems together, I believe there were 60 problems in the study, then this effect gets diluted to only about 0.4 percentage points between conditions. So people do not engage more strongly in discovery-driven search in the condition where they know how many outcomes to expect, presumably because everyone has already experienced the maximum number of possible outcomes in both conditions. The second mechanism is that people gather their own experiences. And so the way we tested this mechanism is by looking at how do people react to the observation of the 4th unique outcome for the very first time. So for this, we needed to identify sequences of 3 problems. So one problem where they have not yet observed 4 outcomes in total, one problem where they have observed the 4th outcome for the very first time, and then one problem afterward where we can then measure the effect of having observed the 4th unique outcome for the very first time. And we were able to identify decisions from 154 individuals from 17 studies that fulfilled these criteria. And in fact, what we find is that immediately prior to immediately after, the engagement in discovery-driven search increases from about 49% to 73%, which is quite a substantial effect according to Cohen's d. And even across the whole experiment, so all problems before and all problems after, it's still an increase of about 11 percentage points and a Cohen's d of about 0.4.
Mikhail, I forgot to say that we like to keep 15 minutes for questions. So in about 10 minutes, it will be time for question, but okay. And then we'll have another 15 minutes for...
Yes, I hope to be finished within the next 10 minutes.
Okay.
Okay, now the third mechanism is using difficulty as a heuristic, basically, on whether there's something missing or not. And for example, think about this very classical problem where one option gives $32 with a 2.5% probability and otherwise nothing, and the other option gives $3 with 25% probability or otherwise nothing. Now, if you cross out any single of these outcomes, then this becomes a very trivial problem, right? So if people have only observed $32 and the other option gave $3 or $0, that's a very easy problem. If they have only observed 0 and here 3 and 0, then this is a very simple problem. And you can go through this basically through every outcome, right? So if people have missed anything, then this is a very easy problem. If they have observed everything, it actually becomes quite a difficult problem where the expected values are very close to each other. So the way we can test for the effect of basically difficulty is by varying the prior in our model. So right now we have an informed prior where people have a rough idea about what they can expect in terms of the expected values, right? And so if they observe something that's very far away from the expected values of the options, then this increases uncertainty to a large amount. If we now drop the informed prior and we use a non-informative prior instead, which is the dashed line, you can see here, the dashed blue line, then the predictive power of the model immediately drops, right? So that's not what people are doing. And so by looking at the gap between the information search, the estimation-driven search with an informed prior and a non-informed prior gives us an idea about how much choice difficulty really contributes to the information search process, which is quite a lot. And the same analysis extends to all different epistemic states. So you can see here the gap between the solid blue line and the dashed blue line is always there and often quite substantial. Now, with the time in mind, let us turn to search termination, right? So how do people decide when they want to terminate information search? If we take the discovery-driven search idea seriously, then we would make the prediction that basically as soon as people have observed the last possible outcome, that's when they terminate information search, because that is what they have been looking for. Now, I want you to really keep in mind that this prediction is quite counterintuitive, because if you use a standard approach to quantifying the uncertainty here, if you observe a new outcome, then usually the volatility increases, and it makes the problem a lot more difficult. And just to illustrate how much more difficult the problem becomes, if we use in our database Cohen's d as a proxy of the difficulty, right? So the difference between the distributions of the experienced outcomes, then in the last 2-1 state, Cohen's d is about 2.7, and in the first 2-2 state, it's about 0.71, right? So the problem becomes a lot more difficult immediately after they have observed the last possible outcome. However, this is what happens in the data, and so the way we quantify it here is we just count the number of problems in which people terminate information search when the uncertainty is minimal. And so people terminate information search in about 80% of the problems when the uncertainty about both options is at the minimum according to estimation uncertainty. And according to discovery-driven search, people terminate in 91% of the problems. So there's again a gap in predictive power between discovery-driven search and estimation-driven search. Another prediction of discovery-driven search is that if people actually stop information search after they have observed everything there is to observe, then they will over-observe rare events at the end of a sequence, right? Because rare events are unlikely to have been observed. And so if people stop immediately after seeing them, then people do basically a kind of p-hacking, but with outcome distributions. And what you can see here is a plot where, again, as a function of the relative sample, in gray, you can see the expected probability of observing a rare event. And in blue, you can see the observed probability of observing a rare event. And as you can see here, as towards the end of the search sequence, people observe more rare events than they should be observing, presumably because they terminate information search right after observing them. And as a final observation that I want to share with you today is the question about what if people don't actually engage in any kind of uncertainty reduction, right? You might remember the fixed sampling rule that is quite often used in the foraging literature. And so here, in this analysis, we looked at a signal of this kind of fixed search termination, right? So if people decide in advance how much information they want to obtain, then we will observe even sample counts much more often than odd sample counts, and particularly due to the computational ease of just dividing by 10, we would observe multiples of 10 much more often. And so here in this plot, you can see the last digits of the sample sizes on the x-axis and the proportion on the y-axis. So what I want you to pay attention to is that if we just randomly, if we have a termination rule, for example, there's a 5% fixed probability to stop information search, then this yellow shaded area is the distribution we would expect. Now you can see that most of the bars follow this yellow shaded area, except for the last digit of sample sizes that end with 0. So people tend to oversample multiples of 10. So drawing 10 outcomes from each option, or 20 outcomes from each option, or 15 outcomes from each option. And within those, the blue area illustrates how many of these allocations are equal between those options, both options. And here, they also allocate almost half of the problems, an equal amount of samples to both options, which is quite a strong signal of people deciding in advance they want to sample, let's say, 10 times from each option, and they stick to it no matter what they see. Okay, so summing up what we have, right? So we asked ourselves, how do people engage in information search? We looked at patterns of exploration in the sampling paradigm based on over 1 million information search decisions. And we made 3 main observations. One is that people rely on multiple drivers of information search, which involve at least 3 types of uncertainty: estimation uncertainty, structural uncertainty, and computational uncertainty. We find that information search that people engage in is shaped by their prior expectations and the knowledge of the environment that is based on the experiences that they have gained in the study. In the paper, we also have a third key takeaway, that there are very strong individual differences between people, but I did not have time to go into detail into this part here. And what conclusions can we draw from this, right? So first, you really need to take seriously how people approach a task and what they do in a task. So there have been a couple of researchers who have called for a more serious engagement with what people actually do, rather than using idealized notions and very simplified agents, decision-making agents in our task, right? So we really need to look in the complexity of human behavior. We might need to abandon the idea of independent observations in an experiment. If people make multiple decisions over the course of an experiment, they learn about the experiment. People have prior expectations when they enter an experiment, right? So we need to really take these properties seriously to form a more coherent or more comprehensive understanding of what people actually do, right? So really, in the future, we need to take into account what people expect. We need to take into account what kind of model they form about the environments that they operate in. And we have to embrace a diversity of strategies that people engage in when they conduct our studies. And with this, I would like to thank you for your attention. You can scan the QR code for the full paper. It's open access, or there's also a link at the bottom of the slide. Thanks a lot for the attention. I look very much forward to the discussion and questions.
Thanks to Mikhail for a very interesting, very elegant analysis. So we invited actually Derek also to present, but Derek, you're okay with his presentation? You're okay. Okay, I think this is very, I was really surprised by those results, and we have now time for questions. And again, sorry that I'm not moving. My camera was broken, but so whoever has question, please raise your hand, and Kinaat, you can start.
I wonder if you took into account like maybe a fourth dimension of uncertainty, which is uncertainty, maybe it's the structural uncertainty about the dynamism of the environment. Like whether people are trying to think when will each outcome arrive. So do you know what I'm okay, I'm going to try to phrase it a bit differently. So for example, it could be that after you saw a rare event and then you stop the search. Do people like go with the valence of the rare event, or do they think now, okay, the rare event just happened, now it won't happen again, so I will not choose it if it was a good one, for example?
So I think I understand the question. The short answer to this is no, we have not considered these kinds of dynamics. As you can imagine, there's like almost infinitely many different kind of processes we could have looked at. We did not look at these kinds of dynamics, and I believe you refer also to things like wavy recency effects here. So I think in the sampling paradigm, because choices and information search are quite separated, in my personal opinion, I'm not sure if Dirk agrees to this, but I think it's less likely to expect people to form these kind of sequential dependencies that will transcend the information search process and basically like leak over into the choice process. But yeah, we did not look at this.
So
Let me
actually,
just-
that was also what we thought too. But when me and Doron Cohen, I don't know if it's here, he's here, but we did the sampling paradigm, and we kind of verified that people do. I'm not saying all people and not all the time, but we found evidence, concrete and significant evidence for pattern seeking in the sampling paradigm. So I'm just saying it's for sure not for small sample sizes, but if people take more than 20 to figure really to check if we can find way your data, that could be awesome.
Actually, it's as a little bit of like promotion of this paper. So like all the data and analysis scripts, they are available on OSF. And in fact, the nice feature of this measurement framework is if you can quantify the uncertainty of any process you're interested in as a function of observed outcomes, you can actually input it in the model, and you can do these kinds of analyses that we did with the other kinds of uncertainty as well. So if you can quantify basically like a signal of pattern searching as a function of what people have observed, you can measure this in our database if there's any kind of signal of this pattern searching.
Yeah, I have a question which is related to Kinneret's question, and also related to the popular approach in this random walk kind of model, or the idea that you sample until you pass some cutoff that is popular in cognitive psychology. So your results appear to be inconsistent with this. How do you call these models, Kinneret? I always forgot their name. This Radcliffe kind of models.
Evidence accumulation models.
Accumulation, yeah. So I think the accumulation model predicts that you will stop after the rare outcome if the rare outcome is high. But if the rare outcome, increases the gap between the expected value, but sometimes the rare outcome can decrease the gap between the two outcomes, between the two averages. I wonder if you looked at that, because that will be a very strong evidence against accumulator models. So suppose you have a rare outcome, but once you see the rare outcome, you are now less sure what you should do. I guess that will be definitely against these models, and also, especially if it's a bad outcome, then it should be against what. Then it will not be. Maybe it will be related to cannot question, but we have to think about it more carefully. But have you looked at this variable?
So I think there's two layers to this. The first layer is even in like the non-experience based decisions literature, people have a very hard time finding qualitative
I lost. It's only me who could not hear Mikhail.
And this goes back to the idea of like the difficulty, right? Options or the choices are usually. Sorry.
Can you repeat what you just said? We can't hear you. Couldn't.
Oh,
Try
sorry.
again,
Yes.
Mikhail.
Yes, of course. So if you think about this idea of difficulty, and let me just go back to this slide here, right? So we usually build problems that are difficult if all the information has been observed. And so we usually don't have problems where the rare event makes the decision even easier. And so that's why it's really, there's no qualitative pattern that these kinds of evidence accumulation models would predict. So it's not generally true that the rare event will push the decision beyond the boundary. It is true that this is at the beginning usually the case. So if like the first or second thing they see is the rare event, then this usually pushes the boundary. but usually we don't observe rare events then, we observe them later. And so it's really not possible to have like a clean analysis. So we thought about this, but because the choice problems are not suitable to test this hypothesis, we did not include it in our paper.
But this result is inconsistent with a popular accumulator model.
Yes. So let me just briefly open the relevant.
Because one thing that is important to understand is that the typical literature that supports the accumulator models, they don't know that they have to assume something about what the subject sees. This paradigm is unique, that you can see the values of the subject sample. So this is a very important. So maybe this is an important observation, because these guys assume many things and then estimate many parameters, and here it's explicit. So you can test this model in a better way.
I think that's a great idea, but I also think the problems, like the structure of the problems, need to specifically designed to test this. I don't think we have with the current data that we have, I don't think we can really do this.
Yeah. Okay, so Andreas?
Yeah, Mikhail, thanks for the great talk. In our study, we found that you have this reversal of the description experience gap in the sampling paradigm, particularly for the risky options, and we speculate a little bit about Bayesian projections could be a reason for the task effects. Did you find any evidence first for whether this selective sampling could explain the reversal of the classic gap? So basically that the overrating of or the underrating of the rare events only appears in the safe versus risky gambles, but not in the risky versus risky gambles in this sampling paradigm. Did you get anything like that, or did you try to also implement the Bayesian model where basically you have a projection? If you experience something, a rare event on the one side, you might also expect it to happen on the other side, which could explain, was our speculation that it could explain the reversal of the tasks.
So first the short answer and then a slightly longer answer. So the short answer is we did not look at choice at all, which includes also we did not relate choice to search patterns. So I don't know if there's a relationship between the information search strategies that people engage in and the choices that they make in the end. So we have our individual difference analysis allows to classify people into the strategies that they use for search, and would be possible to relate them to the choices that they made. I think that sounds like a very straightforward approach to actually see if there's any relationship between this and the choices. But we did not do this.
Okay, thank you.
Mark?
Thank you for the talk. Would you agree that at least some of the results are driven by the properties of your task, and not so much by meaningful and interesting strategies participants follow? For example, the result that they like to search in tens, like 10 information, 20, 30, 40, and equally for both options. This reminded me, for example, we sometimes use a slider that goes from 0 to 100 to measure confidence, and people, that was quite revealing to look at the actual data. They like to answer with 10, 20, 30, but not so much in the middle of it. And I would say that's not very interesting, for example, for the confidence ratings. Is it maybe also the same for some of the results that you found in your study?
I wouldn't say that like any of the results that we find are not interesting per se. I think I mean they uncover the processes that people engage in when they do our experiments, they do our tasks, and if people decide in advance to sample 10 times from each option and then they stop independently of what they saw, then this is an important feature that we need to consider when we analyze the data.
Okay,
so
let me phrase maybe a little bit. Go ahead. Sorry.
Maybe one thing that is quite related to the description experience gap, and is a very interesting pattern, is that this over observation of rare events, right? So if people engaged in these kind of search strategies that people were not aware of before, then they change the environment that they see, right? So basically by doing this, they over-observe rare events, especially towards the end of the sequence. And if we analyze data, assuming like the long-run probabilities of rare events, then we as researchers make a mistake by misrepresenting the actual experience of people that they made. So I think there's a lot of interesting things to learn. Maybe some of them are a little bit disappointing potentially for us researchers because things are more complicated than we hoped they would be. But yeah, I don't think like any of these are like artifacts in a way.
No, I wouldn't say that all of the results are artifacts. That's not what I'm saying. So, but it's not quite clear if they really had the strategy before they start with the task, or if they're guided, exemplified by the counter that they see in the on the screen, and they want to have an even number and so on. So the question a little bit differently framed is to what extent do the results and what results generalize beyond the specific paradigm that you use. Paradigms are very nice because you have measurement practices and so on. It's well established. You can connect to research and so on. But there's also the questions in the room: to what extent results are driven by paradigm.
I think that's a very high-level question. So, I mean, of course, the paradigms that we choose, they are very artificial settings. They're simplifications of reality, and in many cases, people try to find shortcuts to game the paradigm, which does not tell us a lot about how they engage in information search behavior in other tasks, right? But if we zoom out a little bit from like the specifics that people do in a task and the processes that these specific things reflect, I think then we actually learn quite a lot about this, right? So, I mean, I think in isolation, the fact that people are looking for the one missing outcome is not a particularly meaningful observation. But combined with our observation that they know when to look for it, they stop after they found it. That gives us quite interesting insight in how people approach these kinds of problems, and I think they are quite generalizable beyond just the sampling paradigm.
Thanks, Michaela. This is this is the end of the first hour. Now if it's okay with you, we'll stay for another 50. Those of you of us who are free, we'll stay for another 15 minutes of informal conversation. Maybe we can start it, if you stay, by answering some of the questions that are on the chat. Paul Sorkin had a question, and then we can and of course and Derek has provided his own view, so we can talk about that now and during the break and during the last 15 informal minutes.
Yes, of course. Then I would also stop
anyway,
sharing
maybe
my
you should
screen.
start with Derek, because he tried to answer this to contribute to this discussion about importance. Or Derek can actually say what he wants to say.
Yeah, sure, happy to.
Then if Paul is still here, we should answer his question after Derek. Yeah, so Paul is still here, yes.
Yep. Yeah, I was trying to add to Michael's answer to Mark's question, whether some of these or how meaningful some of these patterns are, and in general, I sympathize with your view, Mark, that we shouldn't take some of the patterns we observe in our very abstract behavioral experiments too serious. But I think in this case, sampling round numbers is actually extremely meaningful because it turns the calculation of relative frequencies in a very simple task, and I find it plausible that some people might be interested in doing that. And I think what addresses the point that people might just be stopping at a counter. First of all, I think most studies are not showing a counter. And second, I mean, some studies may. I mean, unfortunately, we actually don't know for a lot of these studies how exactly the study looked like, but at least the studies that were run here at the MPI don't usually have shown a counter. And the other part is really the equal allocation, right? So if you just decide to stop when suddenly you see the counter is at 10, right, then you may not have paid attention to allocating your samples equally across the options unless you're pursuing another interesting strategy, which we haven't focused so much on in this paper, but is also very notable and is demonstrating the richness of this paradigm and the behavior we observe in these kinds of paradigms, is that people might be switching all of the time. That would be one way of maybe then sort of spontaneously stopping when the counter hits 10. But I find it much more plausible, given the combined evidence, that there are literally a number of people that decide beforehand. And this is also something that other literature on optional stopping or search termination in general is pointing to. And it's a reasonable strategy, right? I mean, it liberates you from a lot of computation if you decide beforehand how many samples you want to see and how you want to allocate your samples, right? So why wouldn't people actually do this? And also, why wouldn't this be a strategy in the real world, right? I don't find it difficult at all to believe that some people might be doing something akin to this in real world settings as well, right?
Yeah, I agree. And Mikhail, you want to answer Paul's question, or Paul, do you want to say it express it verbally?
Yes, Paul, if you could clarify a little bit. I believe this refers to an economics paper about markets. I'm not very familiar with this. If you could briefly explain a little bit, it would be great.
Well, maybe Paul is cannot hear us. Okay, that will be good to look at that paper and see the relationship if we don't hear from Paul.
Can I ask another question?
Sure.
If I understand correctly, all your the studies you're looking at, they don't have foregone payoff, right?
Yes, it's people sample from one option at a time. They do not sample from both options at the same time. So
theoretically, you can look at least some of the uncertainty reduction by comparing, right, the like studies with foregone payoff and studies without foregone payoff.
I mean, the problem with foregone payoffs is that they're like in repeated choices and not in like the sampling paradigm. So I'm not familiar with any sample paradigms where people press one button and they get like both outcomes at the same time. So I think this would be the comparison for this. I don't know if this exists.
There are several. I can send you.
Oh yeah, please. That would be great.
Okay. Manos?
Yeah. Hi, everyone. So sorry, Michael, I couldn't be there at the beginning. I got my timings confused with the UK and Central European time, and I joined 40 minutes in the talk. And I have to say, I only read the paper when you shared it to me a couple of years ago, and I never went back to it. But the thing is, and I picked up on that by someone else's comment, is the fact that you're not looking into choice at all. And that's surprising, given that a lot of the exploitation literature has looked at the binding nature of I'm making a choice, and at the same I'm making a choice in order to receive information, but that choice is also binding in a way. And I found that in your design you could have done obviously both, right? So you can see whether some patterns are predictive of certain choices. There is research, for example, earlier research by Ralph and Thomas Hills, where they looked at that. And given these new interesting algorithms that you guys are deploying in this task, I wonder whether there is any sort of indication about whether certain patterns lead to certain decisions, or, and more importantly, I don't know if you do that in your analysis, is whether people learn to sample through consecutive tasks. For example, they sample and then they make a choice, then they move on to the next task, whether they have learned something and they follow that, whether there are sequential dependencies between different sampling rounds.
So we just had an electricity outage. That's why I'm so dark here. Maybe Dirk, if you heard the question, he could answer maybe.
I have an answer Sorry, I have a camera problem. So, but I actually I think it was very nice from Michael and Derek to leave this open question. Obviously, the research suggests that there should be something important to say about this is a natural follow-up research to think what's the implication of the results for the choice. And Eden and I actually wrote recently submitted a paper with that story. And part of the importance is because as Derek meta-analysis shows, there's huge positive recency in this data. So if you stop after you see the rare event, this can explain part of the risky phenomena by Andreas. And this is what our paper is trying to do. So I think that all these papers together help us kind of improve our understanding of the sampling paradigm. But it was nice of them just to publish one paper in Nature. Of course, they published in a very good journal, but they want to have one story and they didn't left some question for other people too. Hopefully my paper will answer part of it and keep some more question for other people. But this is what fun by good research that doesn't solve everything.
Yeah, if I can add briefly, I think it is important to study that link. But I think it's also important to see how search really is a phenomenon of itself, in and of itself, right? There's a lot of complexity there. And I think we were facing the problem of how to bring all of these things together. And probably if we had focused on choice, we probably would have been less able to sort of present so many interesting results about what's going on in search. Yeah, so I think it's a really important phenomenon in of itself. One that also, I think in the history of JDM, I mean, going back to people like Herbert Simon, right, has really been seen as a very important topic. And I think we hope that with our paper, we can maybe establish again that it's entirely fine to study just search without choice within the JDM community. Although really the combination ultimately is what's driving maybe the most important behavior, right?
Just to follow up on that, do you see any, I don't know if it's in the paper, do you see any learning to sample mechanisms, like, for example, because people do a lot of these tasks, right? So do you see that they adapt their search within, okay.
So we do, I mean, we report one important result that is based on the sequence of experiences that people make across multiple problems within a study. Right? So we do see that as people experience a fourth outcome for the first time, then they're more likely to engage in discovery-driven search to find a fourth outcome in the next problem.
Yeah, okay.
What we also see I mean, Michael couldn't present really all of the findings. We also see very interesting sort of dynamic developments within a problem, right? Where people first do discovery-driven search, but then later on engage more in uncertainty-driven search. In fact, and maybe that's also a point to clarify, most of the people actually continue to search quite a bit after having seen all of the outcomes. I think 40% of all samples are being collected in the full information state, right? Which means that people engage multiple strategies, and I'm pretty sure that how they recruit these strategies is something that they learn as a function of the experiences that people make in the problems that they're exposed to.
Andreas, last question.
Yeah, one thought. When we connect this with research on multi-arm bandits, one of the classic comparisons which they do in this paradigm, which is very similar, is about model-based or model-free analysis. And I think, if I understand it correctly, this is, you have here a model-free analysis. What do you think about this? Could this be relevant to perhaps also take this into account, like a model-based search where the people have some hypothesis or model or so?
So I think the model-free versus model-based distinction is quite relevant here, and this is in many ways similar to the question of estimation uncertainty and structural uncertainty. But I think the main difference is basically the question of how do people discover this model. And so in the multi-arm bandit literature, then what people assume is people either like they know from the beginning what the model of the environment is, and then they just seek information to reduce uncertainty about like the transitions and so on, or they have no idea whatsoever and they just repeat patterns of actions that led to rewards, right? And here the question is, how do people get from starting the experiment to forming a model? And this is what we would call like the structural uncertainty reduction. And discovery-driven search is a consequence of them discovering the structure of the environment, of them forming a model of the environment and engaging in kind of like model-based information search. So that's how I would look at the connection to this picture. But of course, it's highly relevant, yeah.
Okay, thank you guys. That was really interesting, and it's nice that there is relationship between different studies that we are connecting, and there's feeling of accumulation of knowledge here. So we're gonna return to continue our summers. Thanks, Mikhail. Have fun.
I think when I meet like most of you, I think I signed the program. Are you going to be in Spuden?
Oh, we're gonna celebrate in Italy. Yeah, I hope to come.
So see you soon.
I won't, unfortunately.
The president was here, but he left recently. Okay, we'll get the president as well. Okay, guys. Hopefully my camera will be better before the next meeting.
Good
Bye.
seeing you all.
Okay, bye.
Bye-bye.
Bye-bye.
Thank you.
Bye. Okay, see you guys. Bye.